Hi guys, I Aziz welcome you to CoedMaster, and in this video I am going to talk about different ways to create an object of HashSet, LinkedHashSet and TreeSet. Apart from this, I will also speak about what are the most commonly used method that we can call on HashSet, LinkedHashSet and TreeSet. So make sure to watch this video till the end. So without wasting any time, let's get started. Alright guys, let's begin this video. So first of all, I will show you 4 different ways to create object of HashSet and LinkedHashSet. So let's begin. So the first way of creating an object of HashSet is, let's call HashSet, give it a name, HS is equal to new HashSet. So this is the first way to create HashSet object using void constructor. You can see here we are not passing any argument to its constructor. Now let's see the next way to create the object of HashSet. So the next way of creating an HashSet is using an existing collection. So let's create a collection of array list, give it a name, al is equal to new array list. Okay, let's add few elements to it, l dot add 1, 5 and 7. Now what do? We can simply pass this existing collection into the constructor of the HashSet. Let's pass it into the constructor, and now we can print this HashSet on the screen. Give it HS, run the program, and you will see that all the elements of this HashSet is being printed on the screen. And this HashSet is created using existing collection. Okay, so this was the second way of creating HashSet. Now let me show you the next way of creating an HashSet. We can create an instance of HashSet by providing initial capacity. Okay, and let's make it 10. So you can see that we can create an HashSet by specifying initial capacity of the underlying data structure, that is array. By the way, in Java, HashSet internally creates an array of size 16. But as we have explicitly defined the size of the array, now this HashSet internally creates an array of size 10. So this was the third way of creating an instance of HashSet. Now let's see the next way of creating an instance of HashSet, and that is by providing initial capacity as well as load factor. So let's give it 10 as initial capacity and load factor as 0.5f. Now as we know that HashSet internally creates an size of 10 if we have specified explicitly. Now what is the role of load factor? So guys, for every insert operation, HashSet internally computes the threshold. Okay, and threshold is nothing but a product of initial capacity and load factor. So for these arguments, the threshold is going to be 10 into 0.5, that is equal to 5. Up to 5 elements, HashSet works absolutely as usual. But what happens when you enter 6th element? So as soon as you add 6th element to this HashSet, it's internally resize itself. So basically load factor is an attribute that defines when to resize the underlying data structure of HashSet, that is an dynamic size array. So guys, these are the 4 ways of creating an object of HashSet. Now you may ask that what are the different ways of creating linked HashSet in Java? So my friend, I have showed you 4 ways of creating HashSet. So guys, these are the 4 ways by which you can create an instance of linked HashSet also. You just have to replace HashSet with linked HashSet, okay? And you are good to go. And why is it so? Because guys, linked HashSet extends the HashSet. So this means linked HashSet possesses all the properties that are available in HashSet. So that is why we are able to create an instance of linked HashSet as same as we have created an instance of HashSet. Okay, so far so clear. Now moving on. Now I will show you some of the most commonly used method that we can call on HashSet and linked HashSet. So let's first create an instance of HashSet. Let's call HashSet, give it a name, HS is equal to new HashSet. Let's add some elements to this set. Let's call HS dot add, give it 1. Okay, let's add few more elements to this set. Let's give it 3, then 5 and then 7. Now what do? We are going to call all the methods one by one. So the first method is the add method. So add method is used to add elements to the HashSet. Okay, now next method is the remove method. So let's call HS dot remove. So what remove method does? This method is used to remove elements from the set. Let's remove 5 from the set. Now let's print the set on the screen. Let's give it HS, run the program, and you will see that 5 is removed from the set and except 5, all the remaining elements is being printed on the screen, 1, 3 and 7. Okay. Now let's see the next method. Next method is isEmpty method. IsEmpty method is used to find if the HashSet is empty or not. Let's run the program. So at present HashSet is not empty, that is why isEmpty is returning false. Now let's see the next method, that is size method. Let's call size. Size method is used to find the number of elements of HashSet. So currently after removing 5, we are left with 3 elements, that is why size method is returning 3. Now let's see the next method. Next method is contains method. So contains method takes object as argument and it checks if the given object is present in HashSet or not. So let's run the program, and as you can see that 5 is removed by this piece of code. That is why contains method is returning false, right? If I update 5 with 3, now if we run the program, it will give us true because 3 is present in the HashSet. Now let's move on to the next method, that is iterator method. Okay. So what is the role of iterator? We use iterator to iterate over all the objects of the HashSet. So let's call it iterator. Let's call hs.iterator, and this method gives iterator in return. Now we can call while loop on this iterator to iterate through all the elements of the set. So let's print all the elements of the set using iterator.next method. Let's run the program and you will see that all the elements of this set is being printed on the screen. So guys, these are the most commonly used method that you can call on HashSet as well as LinkedHashSet. Now I will show you what are the different ways of creating TreeSet, and then I will show you what are the most commonly used method that we can call on TreeSet. Okay. So let's quickly create a new TreeSet first. So let's call TreeSet, give it a name, TreeSet is equal to new TreeSet. Okay. So guys, this is the first way of creating a TreeSet object, okay, using the void constructor. You can see here that we have not passed any argument to this constructor. Now let's add few elements to this tree set. Let's call ts.add, give it 1. Okay, let's add few more elements to this tree set. Let's give it 3, then 5 and then 7. Okay. Now the next way to create a tree set is by using the existing tree set or by using the sorted set. Okay. So tree set is a sorted set. So we can create a tree set using the existing sorted set or tree set. So let's call it tree set, give it a name, ts2 is equal to new tree set, and now in the argument of the constructor we are passing the existing tree set. Okay, here. Now let's print tree set 2 on the screen, tree set 2, run the program, and now you will see that this tree has been created using the existing tree set and all the elements of this tree set has been printed on the screen. Now let me show you the next way of creating a tree set object, okay, and that is passing an argument to the constructor. So let's say we want to sort the item in reverse order. So in that case we can pass a comparator into the constructor of the tree set. So now let's use the existing predefined comparator that is available in collections class. So let's call collections, okay, dot reverse order. Now if we print this tree set on the screen, you will see that all the elements in reverse order is being printed on the screen, 7, 5, 3 and 1. So guys, by default tree set sort all the elements in ascending order or by its natural ordering. But we have passed a comparator, that is why all the elements is being printed in the reverse order. Okay. So this was the third way of creating tree set using comparator. Let me show you the fourth way of creating tree set, and that is using existing collection. So let's create a collection array list, give it a name, al is equal to new array list. Okay. Let's add few elements to it, al dot add 1, okay, 3, 5 and 7. Okay. Now what do? We are going to simply pass the existing collection into the constructor of tree set. Let's pass array list to its constructor. Let's remove this piece of code and simply run the program. And now we will see that the tree set has been created using the existing collection. So all the elements of this collection has been copied into this tree set. And as you can see that all the elements of this tree set is being printed on the screen in ascending order, because by default tree set sorts all the elements of the tree set based on the natural ordering. Okay, so far so clear. So these are the 4 ways of creating an object of TreeSet. Now I will show you what are the most commonly used method we can call on TreeSet. Okay, so let's create a new TreeSet. Let's remove this L. Okay, now let's add few elements to this TreeSet. TreeSet dot add, give it 1. Okay, give it 3, then 5, and then 7. Now the first method we are going to see is TreeSet dot first method. Okay, so first method is used to get the first element of the TreeSet, and that is 1. Okay, now the next method we are going to see is the last method. So last method is used to get the last element of the TreeSet, and in this TreeSet the last element is 7. So that is why 7 is being printed on the screen. Now the next method we are going to see is lower method. So lower method takes an argument and it's going to give us an element whose value is less than the given value. So let's run the program, and you can see that the element whose value is less than 2 is 1. So that is why 1 is being printed on the screen. Now the next method we are going to see is the higher method. Okay, let's call higher method. This method also takes one object as argument, and it's going to print the element whose value is higher than the given element. Now let's run the program, and you will see that 5 is being printed on the screen because the value of element 5 is greater than 3. Now let's see the next method, that is the floor method. So floor method is used to find the element whose value is greatest but less than equal to given value. So let's give it 4. Let's run the program, and you will see that out of all the elements, 3 is the greatest element but smaller than the given value, that is 4. Now let's see the next method, that is ceiling method. So ceiling method is used to find element whose value is the smallest but greater than the given element. Let's run the program, and you will see that 5 is being printed on the screen. So out of 5 and 7, 5 is the smallest number but greater than 4. Now let's see the next method, that is HashSet method. So HashSet method also takes 2 elements as argument, and what it does, it simply return a set of all the elements whose value is less than 2 element. So let's run the program, and you will see that 1 and 3 is being printed on the screen. Now let's see the next method, that is TailSet. So TailSet also takes an argument, and that is from element. So what it does, it gives us a set of all the elements whose value is greater than from element. Okay, so let's run the program, and you will see that 5 and 7 is being printed on the screen because the value of 5 and 7 is greater than from element, and that was 4. Now let's see the next method, that is subset method. So subset method is used to find the subset of the given TreeSet. Okay, and this method takes 2 arguments. First is the from element, and the second one is the second argument is the 2 element. So let's give it 7. Okay, let's run the program. So you can see that subset from 1 and 7 is being printed on the screen. So this time 7 is not included but 1 is included. So if we want to include 7 as well, then we can pass another argument, that is include 1. So let's give it true, and after 7 let's give it true. Now this time you can see that 1 is also included and 7 is also included. So let's run the program, and you will see that all the elements of this TreeSet is being printed on the screen. So guys, I have shown you all the most commonly used method that we can call on TreeSet. I hope you understood it really well. So this was all from my side. If you have learned something valuable from this video, then please hit the like button in order to make YouTube algorithm happy. Please subscribe to this channel, and don't forget to click the bell icon so my friend you never miss any upcoming videos. Thanks for watching. See you in the next one.